Welcome to the second of our annual TEPoP online events. It's great to see lots of you joining today. Thanks for joining us first thing on a Monday morning. I'm Nikki Newton. I'm a Senior Biodiversity Evidence Specialist at JNCC, and I'm chairing today. Hopefully we will be having a really interesting event filled with lots of interesting presentations and discussions today. Just to let you know, we will be recording this talk to be uploaded to YouTube. So please can you keep your cameras off and your microphones muted while the presentations are happening? That would be great. It's lovely to see everyone's faces, but just for the purposes of recording at this point, there'll be lots of time to talk to each other face to face in the breakout group later. So that would be great. So I'm sure a lot of you have probably seen this slide a lot, but we do have some people that I think might not know everything about TEPoP yet. So I just wanted to add this introductory slide in today. So TEPoP is the UK Terrestrial Evidence Partnership of Partnerships, and it was created to bring together JNCC's partners working in the field of terrestrial biodiversity surveillance and monitoring. So those partners listed in the left box here. And they run, fund, organise and steer the terrestrial monitoring and surveillance in the box on the right. So the underlying principle is one of collaboration and knowledge exchange with the benefits of enhancing efficient and effective joint working. Lots of the challenges that we face running the monitoring schemes are shared across lots of us. So it can be really beneficial to discuss these challenges and work together. And since TEPoP was founded 7 years ago, we've expanded this kind of official network of TEPoP partners to engage with lots more organisations who again have similar challenges, and we're really keen to collaborate on you with these discussions, and it's great to see so many of you here today. So we've got lots of TEPoP events planned this autumn, which this is the second. The first is already on YouTube, so please do go and have a look at that if you missed it and you're interested. And this is the first of our kind of 3 themed events this year, which include a mixture of presentations and discussions. And through these events, we'll be presenting work undertaken by the Terrestrial Surveillance Development and Analysis Partnership, which is hopefully very relevant work for TEPoP. And there are opportunities to discuss the work further in the TSDA drop-in sessions. And then finally, we hope to see many of you at a UKCEH event on inclusivity at the end of November, which I know is something many of us have been working on in TEPoP in recent years and continue to think about. So if you miss any events or you want to look back at the presentations, as I say, they will all be recorded and added to the JNCC YouTube channel. And if you have any questions or want any further information, do give us an email, drop us an email at the address in the corner of the screen there. So the focus today is on new types of recording of relevance for TEPoP. So this includes potential new recording using newer technologies such as passive acoustic monitoring, as well as potential types of recording that could be new for our volunteer networks, such as collecting more data on habitat. So some of these development areas are already kind of well on the way to delivering data, while others are still being scoped for their potential, kind of their potential uses and feasibility. So the opportunities they offer could enable huge amounts of new data to be collected, but this can come with lots of challenges. So we'll start today's event looking at 2 areas of work being undertaken within the TSDA partnership. I'll just give you a quick introduction to this in a minute. And then we'll have a talk from Jenna Lawson at UKCEH about the opportunities and challenges associated with using passive acoustic monitoring for soundscapes, before we split into some breakout groups for discussions on the challenges associated with collecting probabilistic data from AI. So there's quite a varied agenda and lots to pack in, but hopefully lots of interesting things to discuss. So just a very quick refresher on TSDA, the Terrestrial Surveillance Development and Analysis Project, which is a partnership between BTO, JNCC and CEH. It was established in 2017 and renewed in 2022, at which point we developed a new strategy. And it works across TEPoP schemes, exploring ways to add value to existing data through cross-scheme analysis and developing analytical and volunteer capability or capacity rather. So current TSDA work is focused on kind of 3 strategic challenges. The first is looking at how TEPoP data can adapt to new requirements for evidence. which will, among other aspects, build on previous work exploring how representative TEPoP data is, and will also consider the need for increasingly devolved and regional information products on biodiversity by producing products relevant to these scales. We'll also explore ways that TEPoP data, potentially in conjunction with data from other sources, can contribute to assessments of progress towards national medium-term targets, which aim to bend the curve of biodiversity loss. The second challenge focuses on exploring how we can exploit or develop new data streams, which involves consideration of how new technologies such as acoustics or eDNA might add value to TEPoP recording, as well as continuing to explore the potential for adding value to data collection by volunteers recording additional information or parameters. And the third challenge kind of underpins the first two challenges, because for any changes to TEPoP schemes to be kind of well received by the volunteers doing the recording, co-design with these volunteers is likely to be really essential. So we'll work quite closely with volunteers through focus groups and national recording schemes, and we'll assess the risks and benefits of any proposed changes. And then, resource permitting, we may also consider the volunteer experience in terms of the feedback they receive from schemes. So yeah, kind of fewer flowers and far more words on here, which you won't necessarily be able to read all of, but it's attempting to set out the TSDA work programme as simply as possible. And hopefully it might be useful to refer back to, even if not to read all of now. And because the challenges set out in the slide before are kind of the aspirations of the TSDA partnership to work on up to 2027, because we can't work on all of those immediately. So this table kind of sets out the key areas of current TSDA work and those starting imminently, to highlight the areas we're focusing on now. We also have a parallel biodiversity pathways project just starting, which involves TSDA partners and the University of Cambridge, exploring the biodiversity impacts of policies. So this table also highlights at which of the different TEPoP events we'll be discussing different tasks. And we have a sort of TSDA follow-up drop-in sessions on the 20th of November. And these sessions have been really useful in the past to kind of steer the work packages and to engage TEPoP partners in those pieces of work. So it would be great to see lots of you at those. And today we're going to be focusing on two of the work areas which contribute to our exploring new data streams challenge there. So firstly, today, next on our agenda, we'll be hearing from Maddie and Kirsty on the recent work they've been doing on scoping the potential for recording habitat with citizen scientists. So over to you, Maddie.
So as Nikki said, I'm going to be talking to you about some work I've done over this last year on understanding citizen scientists' motivations for recording habitats, and I'm then going to be handing over to Kirsty, who's taking this work forward to talk to you a bit about a forward look. So the aim of the piece of work I undertook was around understanding volunteer interests, motivations, barriers, confidence levels around recording habitat data. We were particularly interested in this from the perspective of using this to validate Earth observation data, but we were also interested in many other use cases that habitat data could be used for. This links into all three challenges of the TSDA strategy, validation of EO data being an emerging critical evidence gap, the potential addition of habitat data being a potential new data stream to exploit, and obviously asking volunteers what they think through a survey, tying in very closely with challenge 3 of developing a volunteer-centric approach to the evolution of TEPoP schemes. Next slide, please. So we put out 2 surveys. One of these surveys was more general, aiming to understand motivating factors, barriers, etc. And the other being more specific, looking at a particular habitat recording app, EarthTrack, as one potential option for additional habitat recording, with the aim of seeing some of these responses a bit more in context if we were actually getting users to go out into the field and record habitat data. How do motivations change compared to doing it in theory as in the first survey? These surveys were developed in collaboration with a steering group. So thanks to any of you on the call today who were part of that. We had representatives from a number of different schemes and anyone else who was interested based on this event last year. And the app survey was also developed in collaboration with Aberystwyth, who developed the EarthTrack app. We circulated these surveys through social media, newsletters, and again, a big thank you to everyone who helped out with circulating these across various different schemes. We got a good response. We had 458 people respond to this first survey, and we had 48 people respond to the second one, which was a bit more involved and actually needed people to go out in the field and test out. So I think both of those are really good response rates. We were really pleased with that. Next slide, please. If I run you through some of the results from these surveys, firstly, in terms of how interested people were in this, we were quite surprised with the high level of interest that people had. We had between 79 and 82% of respondents answering 4 or 5 on a scale of 1 to 5 of how interested they were across various different types of habitat recording. So whether this was more general habitat like woodland, grassland, or more specific habitats like oak woodland or calcareous grassland, or looking at specific features or land management. So whilst recognising the likelihood of bias in this type of question, I think those who choose to complete a survey like this are likely to have some level of interest, given that they clicked on the link and took the time to fill in a questionnaire about habitat recording. I think the more interesting thing is that the high number of respondents in total indicating their level of interest. So more people responded saying they'd be interested than there are current participants in some of the UK's national citizen science schemes. So just through sheer numbers, yeah, very positive. Next slide, please, Nikki. We then presented people with some information about what habitat data could be used for and asked if their level of interest changed based on this. And we found that for most people, they didn't report any change in their level of interest after being given this kind of information. However, we did find that those who did show an increase in interest were typically those who were already most interested. So I think that's quite interesting because it shows that communicating data uses and the importance of data collection is a more important tactic for further motivating those who were already interested, rather than motivating people where there isn't motivation in the first place. Next slide, please, Nikki. We then asked people about potential barriers to recording habitat data, and we found that lack of time and lack of confidence were by far the most significant factors, whereas factors such as lack of personal interest, not clear why it's needed or valuable, or feeling that they already do enough were less significant factors. Next slide, please, Nikki. In terms of confidence levels, we were also quite surprised how high people ranked themselves in how confident they would be, with 73% stating they'd be confident in recording all types of general habitats. We did find that the confidence did decrease for finer scale habitats, so the more specific habitat types or land management features, but this did still remain fairly high. So between only 6 to 8% of people stated that they wouldn't be confident in recording any types of specific habitat types or these more specific features. However, it should be noted that an individual's perception of their confidence and their actual accuracy may not align. Next slide, please, Nikki. There was also, we found only a very weak correlation between confidence and interest. You might expect those who are most interested to also be most confident, but we didn't find that to be the case. This is interesting because it suggests there could be a demand for training to improve confidence. Next slide, please, Nikki. In terms of what training people might find most useful, we found that instructions to follow in the field and ongoing support were the most popular options, whereas options such as in-person training in the field and interactive online training were least popular, which I think is interesting because they would also be the most resource intensive to put on. Next slide, please, Nikki. We also asked about the type of feedback they'd be interested in. So if they were to go out and record habitat data, what would they want to know in terms of how that's being used? And we found that case studies, graphs showing how habitat's changing over time, and the information about the habitat that they've recorded were the most popular, with validation of results also being fairly popular. Whereas things like leaderboards and tracking personal achievements were much less popular. Next slide, please. We got quite a range of different types of respondents. Most people were already current citizen scientists. They had taken part in an environmental recording scheme within the last year. But we did get 48 respondents, so that's about 10% of the total, who are not current citizen scientists, so would be new to recording. A lot of the people who responded also recorded for more than one scheme. And you can see the breakdown here of which schemes, and we do have a breakdown of results by scheme, so we could send that on individually if anyone's interested in that. Next slide, please. Most of those who were current citizen scientists said that they would prefer to undertake habitat recording at the same time as their current recording, rather than new or additional visits. Next slide, please. Moving on to the second survey around the EarthTrack app as a use case, we found people ranked it kind of middling on user friendliness. And interestingly, it was actually the non-experts who seemed to find it more user friendly than the experts. Next slide, please. In terms of their confidence in actually being able to answer the questions that the app was answering, we found this was quite high as well. Most people putting 5, very confident. But the non-expert trend did reverse in this question, with non-experts having lower confidence, as you'd expect. Next slide, please. There was strong interest and support here as well for training to improve confidence, regardless of the current level. Next slide, please. We also found that quite a high proportion of users said that they would sometimes use the app again. We didn't have many people saying they would use it very often, but I think the way the app's designed, once you've recorded somewhere, you're less likely to record there again very often. So this probably makes sense. And we also got quite a lot of really useful free text comments with specific ideas around how to improve the app. Next slide, please. So just to conclude, I think these surveys show that it would be feasible to make use of citizen scientists to collect more habitat data. There is interest in this. So UKCEH with the work going forwards in a minute. But I think the second point that would be useful to highlight, particularly more broadly, more applicably across TEPoP and TSDA work streams, highlighting that we should ask volunteers what they think, rather than relying on anecdotal evidence. The picture we got out of the survey was a lot more positive around volunteer motivations than we'd previously believed, based on more individual conversations. So with that, I'll hand over to Kirsty to talk about work going forwards.
Thank you, Maddie. As we just heard from Maddie and from other previous work on this topic, we know that there's a growing need for the habitat data for a range of applications, and that there's a lot of scope to record habitat metrics, either integrated into existing taxon monitoring or as a new standalone scheme. What we're planning to do going forward does again link with the main TSD aims. JNCC really is ideally placed in setting up some of this new habitat monitoring and investigating on the kind of schemes that would work. But we will need to do this together with our partners and in consultation with the main stakeholders. Next slide, please. So building on all this previous work, our next objective is to develop a roadmap for the collection of habitat data through the volunteer recording initiatives. We want to ensure that what is collected has real value for the users. And so there's a lot of work that still needs to be done in the first place to make sure that what we will ultimately propose to take forward will be both realistic in context of the existing monitoring schemes and will produce data that are what our stakeholders actually need and make use of. This process will involve a number of key actions and considerations. Having identified our main stakeholders and their needs for habitat data, we will then be in a position to determine what the focus for any new habitat recording ought to be. For instance, is it going to be mainly used for EO validation, or whether we will be aiming to collect more detailed data that would be useful for co-analysis with taxon data to investigate drivers of change, for instance. Exploring the options for a habitat classification to use for the surveys is an important consideration, because it needs to be detailed enough to enable the relevant kind of habitat data collected, but at the same time it needs to be a compromise that what we are asking the volunteers to do is within the limitations of what is practical to us for a volunteer network, which is where Maddie's work, we just heard about, is going to be very relevant indeed. As well as using the habitat data validator habitat maps, then we want to also look at how these habitat maps in turn can then benefit the schemes themselves. And we're going to take forward looking at the recording tools and putting forward proposals on what kind of recording tools would be best for any future scheme. So while we are going to be encouraging the existing surveillance schemes volunteers to take on habitat surveying alongside their other activities, then we're having an ideal opportunity at the moment to also engage with new audiences as well. So until we've done some further investigation, we're completely open into whether we're going to be proposing incorporating the habitat recording into existing schemes only, or whether it's going to be more to develop a new scheme or some kind of hybrid of the two. Next slide, please. So the ultimate aim of this work will be to facilitate the generation of accurate habitat data using standard protocols across the whole UK for the benefit of TEPoP schemes and the wider stakeholder community. Having access to accurate habitat information does have a variety of benefits to you, our TEPoP partners, ranging from the ground truthing of EO imagery to monitoring impacts of a range of the environmental pressures on priority habitats, just to mention a few. Next slide, please. So to achieve this all, we will need your help with defining and developing the habitat surveys and eventually piloting the surveys. We wanted to make this process as consultative and collaborative as possible. And so I will be contacting many of you to set up more detailed discussions in the next few weeks to help define and develop the habitat surveys and to set up some of the survey pilots, perhaps sometime when we get to next summer. A lot of this is likely to take place in task groups, so the work can be aligned across existing TEPoP projects. In terms of timescales, we're aiming to complete the scoping phase and the development of the roadmap during the current TSDA year and have the report ready in September 24. Next slide, please. So finally, I would like to finish off by highlighting the TSDA dropping sessions on the 20th of November. The habitat monitoring session will be at 11:25 for half an hour, and I would love to see many of you there to start these discussions. Thank you.
Thanks very much, Kirsty. And I just wanted to highlight as well on the bottom of this slide, there's a link to a Jamboard, which if you click on it, it has a slide, a Jamboard slide per TSDA task that so this will be applicable throughout the events over the next few weeks. If you want to ask any questions or put any comments down or express interest in being involved, then please do go and use that resource to engage with the task as well. So thanks very much, Maddie and Kirsty, for that introduction. I think looking at time, I'll move swiftly on to the next of our presentations, which I think is being presented by Michael today in Diana's absence. So I'll pass over to you now, Michael. Thank you.
Okay, thank you so much, Nikki. Just to let you know, I think you'll need to put that link in the chat in order for people to click on it.
Yes, sorry, we will do that.
Brilliant. Okay, yeah, thank you so much. So new technology is one of those things which we talk about quite a lot. We can get quite excited about in terms of its potential and all the rest. And sometimes for those of you particularly who engage with volunteers, sometimes you might feel a little bit jaded about all this talk about the new shiny technology, whereas actually we've got really great monitoring systems through the engagement of volunteers already. What we wanted to do within this piece of work, which was led by Diana, but as Nikki said, she sends her apologies for not being able to give this talk today, was to scope out some of the potential for new technologies. So on the next slide, there's a diagram which was from a paper by Mark Besson, and they were talking about having ecosystem monitoring systems and exploring the potential for new technologies to be involved in those. And so you can obviously look at the paper and explore some of the things which they talked about. Now, some of these you could see immediately would be could be great or could have potential to be applied within the context of a volunteer monitoring network or citizen science, whatever you want to call it. Some of these might be a little bit more out of scope for what we directly might think of in terms of the potential for citizen science and volunteer engagement. So on the next slide, it says the aims about what we wanted to do, which was to scope the application of new tools and technologies for monitoring in the UK and to assess a broad range of these tools and technologies. We didn't want to just restrict ourselves to the old classics like remote sensing and DNA, but to really explore the breadth of what was possible. And so on the next one, you'll see then some of the different technologies that we considered, for all of the technologies that we considered, under these broad headings of data collection, data analysis and processing, and the user experience. So you can sort of think about that as a bit of a continuum in terms of people's engagement and the way of getting data. And so some of these I imagine that you might be familiar with, things like acoustic sensors and DNA technologies are already have been piloted in the context of TEPoP networks in various different contexts. Things like drones may be less obvious, but I'm sure many of you will know what they are. But then when it comes to thinking about things like, well, what's the potential for radar, this upward pointing radar, or robots? You might even say, what on earth is blockchain? There's a wide range of different things where it could have relevance to the way that we do things, the way that we think about data. It could have relevance at different points in the data. So things like the acoustics are much more about the data that we collect. Things like the blockchain is actually a way of storing and sharing data in a very open and trusted way. You might have heard of it in the context of cryptocurrency, but it can be used within the context of large data sets, open shared data sets, in this way where, in particular, we're able to think about attribution of or sort of recognize people's contributions much more clearly within that context. So anyway, I'm not going to go through all of those now, but you can see the range of different technologies that we thought about there. And then on the next slide, we wanted to think a bit more about what the benefits of these different new technologies might be. So you can see them there, and I'll just run through them quickly. New technologies, as appropriately applied, can be helpful in terms of reducing errors within existing data streams to improve their collection and curation. Clearly, we know that the data that we collect from volunteers is gappy in terms of space, in terms of time, and in terms of taxonomy. And different technologies could be really helpful in recording, basically recording in the places that people either don't go or don't want to go, don't choose to go, or in with the sort of taxonomies that people cannot easily work with. So things like working with estimating soil quality could be something that people might be great at being able to support, but are not going to be able to do it in terms of the traditional species monitoring that many of the TEPoP schemes use. Can use tools like DNA for whole ecosystem monitoring. And when you've got sensors out in the field, there's actually the potential to co-locate things like pollution sensors with either the volunteer recording or other forms of sensors, which can then much more closely link threats or interventions with the outcomes for biodiversity. Technology can help collect additional species data. Things like species interactions could be collected much more fruitfully or efficiently with this. And sensors can also support the real-time monitoring, particularly when there are permanent or semi-permanent in-field sensors. All of this can lead to cost efficiencies. Not in every case, obviously, but in certain cases, they can lead to that cost efficiency. And it also means that some of those tasks which we might ask volunteers to do, actually they can be released from if there's technology in order to support that. It just means that there's more time for volunteers to do the stuff that they love, to engage more with nature. And actually, in terms of the fulfillment of the tasks that they get, technologies, thinking down the latter end of that user engagement that I talked about, technologies can really help people in terms of providing the feedback and that bespoke and real-time engagement of people with the data that they're collecting, which can be really motivating to people. Can help with societal engagement because it means that people don't need to do that species identification, and things like DNA or acoustic data can be stored in perpetuity so that it allows people to come back to it. So many benefits of in exploring these technologies. What might be the challenges? Those are on the next slide. Well, sometimes it could actually exacerbate these existing spatial, temporal and taxonomic biases that we've got. Technology can lead to increased waste or pollution. The disposable sensors out in the field or the plastic waste associated with DNA analyses, and could also lead to new ecological disturbances with the thoughts of drones flying over sensitive places and things like this. Although we might be able to get lots more data of particular types from new technologies, actually by not having people in the field might actually reduce the knowledge. There's nothing quite like having good natural historians out in the field to really be able to indicate and ask good questions about what's going on. Technology is changing rapidly, so putting too much emphasis on this rapidly changing technology could cause problems because we lack consistency of methods, but it also might be that some of these technologies in time we invest in terms of their early development, and they may actually fail to deliver on the promise or the hope of what we hoped would be delivered there. And so these are all risks associated with technology. It can conflict with traditional sampling, and what we'd ultimately be looking for is to complement or enhance traditional sampling, not simply conflict with it. And citizen science methodologies can actually provide a really valuable reason for people to go out there and to engage with nature. It can be a really good route in to enhance people's nature connectedness, and taking some of that away by replacing it with technology could actually be to the detriment of the volunteers. And clearly, technology could open up opportunities for greater societal engagement, but used poorly, it could lead to continued exclusion of some underrepresented groups. So there's a wide range of different things. Just wanted to explore a couple of specifics. So on the next slide, things like the Bat Conservation Trust have been exploring this idea of the Internet of Things or wireless sensor networks to be able to help in terms of monitoring bats and bat roosts and things like this with this dispersed network of sensors linking to hubs, which then link back to databases in real time, providing scientists and those interested in monitoring the bats with that real-time monitoring as to what's going on. On the next slide, you can see reference to a paper where they've been talking about using machine learning to process and analyze the data. So we know that some of the unstructured data that we get from volunteers can be really messy in terms of a data set for analysts to deal with. And so machine learning can provide these ways of being able to learn patterns within the data. We need to use it carefully, but this study in particular showed how it has been used really effectively to be able to flexibly model those data and account for the sampling heterogeneity. And then on the next slide, there's an example from MyDecide, where we had 800 people signed up a couple of summers ago to receive automated bespoke feedback on the impact of their recording. And we tested a range of different methods to give people feedback in this automated way, but clearly demonstrating the potential of this bespoke feedback and the technology to provide that for greater benefit to people. And so going on, how should we determine our priorities within the context of TEPoP? So within the TSDA project, we're able to explore some of these new technologies, but we wanted to think about that. And so we wanted to explore it against all these different technologies against these three axes. Firstly, in terms of technology readiness. So it's we can explore investing in those technologies which could be implemented tomorrow if we really wanted to do that. We also wanted to explore commonality across schemes. So there are some of these technologies which are going to be absolutely fantastic for something really, really niche. That's great. That could be really valuable. But in terms of thinking about where we can invest our time and our thought, it feels like it's really beneficial to look at those things that are going to add those benefits across schemes. And with those two, it's really about that thinking about what we can do in terms of enhancing the existing monitoring or augmenting the existing monitoring. So doing that. But the third thing would be the potential to transform monitoring and our monitoring pipeline. And that could be the sorts of things which maybe technologies are not going to be applied for the next few years, but it's really important to invest in them because we can see that transformative potential. And so just three examples. There are aspects of machine learning, going on to the next slide, which could be really valuable and could be applied very, very quickly over the short term. Some of these verification tools, in particular using aspects of machine learning or learning from big data, could be really helpful and could be applied widespread across schemes. And thirdly, some of the DNA tech, actually, yes, it is being applied in specific circumstances at the moment, but it has the potential to really transform monitoring in a range of different ways, whether that's using diagnostic DNA technologies, using much more broad spectrum technologies such as the next generation sequencing, and how we can do that and how we can best do that is something that I think has the potential to transform what's possible and really add on to what's possible with volunteers. And so coming up, what we've got is we've got a workshop to discuss priorities for the TSDA investment. We want to ask people and ask your opinions about how we should decide those priorities. So should we be looking at these low-hanging fruits, the things that could be applied tomorrow if we had the right schemes to do it, or should we be much more forward-looking, looking at the sorts of things that could be transformative in 5 or 10 years' time? What are the benefits do you think are going to be really important for us to exploit within implementing new technology? And what are those concerns or challenges that we really should be looking to minimise, the things that set your alarm bells going? And so we've got 2 ways of you engaging. The first one is we've got a TSDA drop-in session on the 20th of November. So that's just before the Habitat one that Kirsty just talked about. So come along, join in, and you can give your 25 minutes worth of thoughts, engagement, all sorts of things, and we can see where it goes. And secondly, we're going to have a longer workshop, which will be held early in next year in order to plan these next steps. So email Diana if you're interested in participating. And obviously more information about that will be available at the TSDA drop-in session. And so I will leave it there. Thank you, Nikki.
Thanks very much, Michael. That was great. Hopefully, as we've mentioned, make the most of that Jamble session. We'll hopefully see lots of you on the 20th. I'm going to pass on swiftly to our next speaker, which is Jenna Lawson from UKCEH, who's going to talk to us about exciting things to do with passive acoustic monitoring and soundscapes and what's possible there. I think just in order to catch up a bit of time, if you're happy, Jenna, we'll invite questions in the chat, but we might then answer them by email and on the YouTube video as text afterwards, if you're happy with that.
That's fine, yeah.
So please do keep and ask your questions to Jenna in the chat, but we'll answer them after the event. So thanks very much. And I'll pass over to you now, Jenna. Thank you.
Thank you. I think we need the next slide. Yep. Okay, hi everyone. So today I'm going to talk to you a little bit about a specific type of analysis that we can do with acoustic data called soundscape analysis. So I'm just going to go briefly over some of the acoustic technology that's out there, some of the practical applications of acoustics in general, and then we're going to delve into some examples of soundscape analysis and one species-based AI analysis so you can see the differences, and then just briefly discuss some of the sort of benefits and limitations of each methodology. So next slide. So there's been an explosion in acoustic technology over recent years. No longer are devices sort of £600 a pop. And if you look on the bottom right-hand corner, we've got the audio moth devices, which many of you have probably heard about. These are a little bit more basic in terms of you put the batteries in, you put your memory card in, and you start recording. They've developed smaller devices called the micro moth. We've got the audio moth dev, where you can plug in external microphones and external battery sources. And they're designed for very different purposes and very different studies to, say, the other 3 images that we've got here. So, for example, with these other 3, they run on telemetry, so you don't need it, the data is sent back over a network, so you don't need to go and collect your data cards. A lot of these run on solar power, so they can be left in the field for really long temporal scales. So very different devices, very different prices, and very different applications depending on your locations and your questions. So next slide. And so once we've got this acoustic data, there's 2 broadly, I'm simplifying this, but broadly 2 different things that we can do with it. We can look at fine scale sort of species-based analysis by training AI classifiers to recognize species sounds, or we could even use citizen science for people to go through the data and pick out individual species. Or what we can do is something called soundscape analysis, which is a more broad measurement of the data. So it's not going to give us individual measures of species, but it'll give us a broad idea of what's going on with the environment. So next slide. And just to go over some of the practical applications of these two methodologies, just so you can see the differences. So with our species classifiers, once we've trained the classifier to recognize the calls, we can essentially pull out all the different sort of forms of analysis that we would do with traditional methods. So we could do species inventories, we could look at population parameters such as abundance and density, although there's a caveat, they are a little bit harder with acoustics. We can look at community parameters such as functional diversity, species richness, species distribution, occupancy modeling, interactions between species, and even behavior of individual species. So there's lots of fine scale information that we can get there from our species-based analysis. Whereas soundscape analysis, it's not really going to tell you anything about the individual species that are within the soundscapes. It's not going to tell you about species that are within the recordings. What it's going to do very broadly, and again, I'm simplifying this, but it's going to tell you the level of sounds in your ecosystems. And we can roughly break this down into biotic sounds, abiotic sounds, and anthropogenic sounds. Although there is a lot of crossover between those with the indices that are used. There has been a lot of papers that have shown the indices that we, so these index values that we get from using soundscape analysis are correlated to things like species richness and abundance, but that does vary considerably across the literature. So what the soundscape analysis is going to do is just give us a general idea of the levels of sound in the ecosystems and the level of biotic sounds that we're seeing in these ecosystems. So next slide. So this is just an example of some sensor networks that we've set up. So the one on the top right-hand side is a study in Costa Rica where we paired acoustic recorders with camera traps to look at the differences along a gradient of anthropogenic change across the region. And you'll see a similar map in the middle. That was a species-specific analysis looking at the distribution of the spider monkey. And then the one, for example, on the left-hand side, that was looking at biodiversity increase in restored ecosystems in Brazil. And next slide. So I'm just going to talk now a little bit, just give you an example of a species-specific data study that was done, just so you can see the level of detail that we can actually pull out. So next slide. So this one, if you look at this map on the left-hand side, so this is a land use map, and it's an area called the Osa Peninsula in Costa Rica. And what we can see here, all the dots, the pink dots and the white dots, are the recording locations. So we had out here about 400 recorders, and the aim of this was to look at the distribution of spider monkeys in the area, because they weren't dispersing in the forested region as much as they were expected to. And if you look at the map on the right and the right-hand side, sorry, you can see that very black blob at the bottom. That's Corcovado National Park. It's a highly protected national park. And then if we go back to the map on the left-hand side, if the white dots are all the areas where we found the spider monkey on the recorders. So we trained the classifier for the sounds of the spider monkeys, and then we ran that over all of the data, and then it told us which recorders we were seeing the spider monkeys at. And so from this, we could roughly map the distribution of the spider monkey. We can see that they're still only found in and around this protected area, the national park. We were able to look at their reactions to paved roads, to gravel roads. We were able to look at the effects of land use, percentage forest cover, distance to villages. So there was a lot of really fine scale information that we could get there. And from this, we were able to design a biological corridor through the region for the spider monkey. So that's an example of a species classifier and what we can do with the species-based analysis. So next slide. But there are limitations with the species classifiers, and I think it's probably down to these limitations that soundscape analysis has become so important, and it does give us a lot of different information. So it's very difficult to get training data. This is one of the main limitations of species-based classifiers. For example, it took me 3 months to collect the calls needed to train the spider monkey algorithm. Especially for rare species, it's very difficult to find these calls, and you can't find all the calls from one recorder in one location. You do need quite a varied, your training data needs to be quite varied for it to be successful. Annotating this data is quite hard. You do need experts to spend many hours going through and annotating the data. Training of classifiers, it's getting a lot easier with different packages in R, and sort of more, there are sort of more web-based training that you can train it on web-based applications now. But training of classifiers has traditionally required quite a lot of expertise. And even once these classifiers are trained, the validation of these classifiers and the quality of these classifiers, we need to make sure that they actually work across regions. And as I said, the expertise required for analysis. And there is a lot of bias in our classifiers at the moment for common species and geographically. And so next slide. So I'm going to talk a little bit about soundscape analysis now. So next slide. So this is an example using the same data set from Costa Rica, from the Osa Peninsula, and I'll just briefly talk through these images here. So we had recorders in old growth rainforests, in secondary forests, and then in 2 different types of plantation, in teak plantation and palm plantations. And the idea here was to look at the level of roughly the level of biotic sounds within these ecosystems, to see how healthy the teak plantations were and the palm plantations were in terms of biodiversity. And these black boxes that you see across the middle of the screen, each one represents a dawn chorus in the habitat. And what you can see is along the x-axis we've got time, and along the y-axis we've got frequency. So very roughly, the more lines and the more colours and the more space that's filled, as long as you're in more natural ecosystems, we can roughly translate that to there being more biotic diversity in the ecosystems, just more levels of sound. So I think you can probably understand what the images are doing already. We had lots of biotic activity in old growth forests, slightly less in secondary forests, but still very healthy. And then in teak plantations and palm plantations, you can see this very sort of, it's just one sound dominating the ecosystem. So we've got a lot of black space still, which indicates that there's not a large variety of sounds, and there's not a lot of sounds in these ecosystems. So you can see instantly from this that we can roughly quantify the levels of biotic sounds and biodiversity within ecosystems. I should say there are caveats to this. There is a correlation of these indices with anthropogenic sounds, and with geophony, such as wind and rain, can disrupt the soundscape indices. So you do have to be careful with your interpretations. And then just an extra level of analysis at the bottom, if you look at these orange graphs along the bottom, what we were actually able to pull out from this, which was really interesting, and it shows the benefits of doing DL cycle recordings and not just recording at dawn and dusk. What we can see here is we can see, again, we've got time along the x-axis, and we've got indice value along the y-axis. And these peaks that you can see in the first 2 graphs especially, they're our dawn and dusk choruses. So you can see it looks as we would expect in a healthy ecosystem. We've got quite a big dawn chorus and a smaller dusk chorus in the old growth and secondary forests. That's slightly dampened in our teak plantations, but we do still have some dawn and dusk chorus. Whereas in the palm plantation, we've lost that dawn and dusk chorus altogether, which was really interesting to see. So that's one example of how we can use soundscape analysis. So the sort of analysis and the data and the insights that we can pull out. And then next slide. So I don't know if this video is possible to play. This is just a little bit of a fun video showing you some, I think, if it's going to work. It's very jerky for me. So this was some field work that we did in Croatia, and what you're seeing there, I don't know if you could play it again maybe for people while I explain. What we're seeing there is a drone that was modified with a shooting mechanism to put acoustic recorders in the tops of canopies, because what we recognized is that the top of the canopy in a forested ecosystem is very different to what we're seeing on the ground. We have a very different set of species. And what most of us do with acoustic recordings is we take them at roughly ground level. So we're missing a lot of what's going on in that upper canopy. So this is, the drone is actually shooting an arrow into the tree, and in the head of the arrow is an acoustic recorder. And so what we were doing is we were taking measurements from the top of the canopy and the bottom of the canopy to look at the difference. So if you go to the next slide. So we did actually do species-based analysis on this using BirdNet, and we did soundscape analysis. And from our species-based analysis, we did find a 30% difference in species between the top of the canopy and the bottom of the canopy. So we are, if we only take our acoustic recordings in the shrub layers, we are missing a lot of the species. And we can also see here in terms of soundscapes, the canopy soundscape adorn chorus at the canopy on the left-hand side, and then in the shrub on the right hand side. And again, this was a highly forested ecosystem. There wasn't a lot of anthropogenic influence. So we can see that there's a lot more sounds in the canopy than in the shrub layer, which was really interesting. And this, I haven't written up this paper yet, so this should be published within the next few months, hopefully. So next slide. And again, this is another little video. This is another project from my time with the robotics department. So this is a flying sailing drone. And again, we were using this drone to try and make acoustic recordings in a non-invasive way in aquatic ecosystems. So the drone flies onto a lake or a water body, and then there's a hydrophone that drops down underneath the water and makes underwater recordings. And if you go to the next slide. Again, we perform soundscape analysis on underwater data this time, and what we can see here, it's just a PCA, and we can see the separation between the two different methods. So what we were basically trying to show here is more traditional methods of acoustic monitoring on a buoy, for example, with an acoustic recorder attached to a buoy, and then our moving method, the methodology of like sailing transects across a lake. And we can see that we were able to collect completely different data and show the difference in the soundscapes between these two areas. So they were just two fun examples for you of soundscape analysis. So next slide. So, but there are limitations of soundscape analysis, and I touched a little bit on this as I was talking. So we don't have any assumption of what the sound is unless we go into the recordings. It's not telling us what species we're actually hearing. They are very broad measures, but I do think they're very useful in combination with other methods or other forms of analysis. There are so many indices being developed at the moment. I think there's probably more than 70 different indices at the moment being used, and everyone seems to be doing something a little bit different. So it's very hard to make comparative studies. The anthropogeny and the geophony are correlated with the indices, and there is an issue. So I think I said that we can sort of look at biotic sounds within an ecosystem, but we also have to recognize that the indices and the analysis is probably picking up on non-biotic sounds. So we do need to be careful with our conclusions. And these indices and the analysis is sensitive to geographical and temporal differences. And we've seen very different results with the indices in different locations and at different times. They are affected by recording schedules as well, which is something that people are trying to standardize across the field. And there are big questions of whether they are actually correlated to richness and abundance. A lot of people have found that they are, but again, some studies have found that they're not. But there are quite a few recommendations that have come out of the large amount of work that's been done on soundscape analysis. And the idea is to use multiple indices rather than just one or two indices to really know your environment. So for example, I did some work in a grassland environment, and right next to my recorder in this field in the tropics was a huge group of parakeets that just sung constantly day and night. And so it looked like there was large amounts of biodiversity in my grassland environment compared to my forested ecosystems. But actually it was just these parakeets dominating the entire ecosystem. So you really do have to know your environment and be careful with your interpretations. I would definitely recommend recording across the DL cycle. As you saw in the example, we wouldn't have picked up on those changes if we hadn't done. Always take supportive measures. I think soundscape analysis should be used in combination with other methods, and sort of be realistic as well in what your indices can tell you. So next slide. And so, oh wow, this has come across a little bit, okay, this it wasn't supposed to look like this slide. So just some of the pros and cons of acoustics in general. So I think acoustics, as someone who works on solely acoustics, I am an advocate for acoustics. I think the method is a lot less invasive than traditional sampling methods. We do have an ability to capture rare species on these acoustic recorders. There's less observer bias. We can answer multiple questions and look at multiple species with one data set. It is possible to monitor human activity with acoustics as well. And we can really increase the spatial and temporal scale and coverage of our work as well. And it allows us to access areas that we weren't previously able to access. And again, there's a big reduction in person power with acoustics as well. But with all these advantages does come some limitations. The sensors are quite expensive and are susceptible to environmental damage. The quality of sensors is improving, but you could leave your sensor out for months and then come back and find that it stopped working after a week. So installing sort of more remote health checks on systems where you're going to leave them out for long periods of time is really important. We are quite limited by the reference core libraries and classification tools right now, but there's a lot of work going on to improve these. For example, BirdNet, it has, I think it's well over 1,000 species on BirdNet at the moment. The bat classifiers for the UK are fantastic. But with the acoustic indices, as I discussed, some of them are poorly correlated to traditional biodiversity measures, and we're constantly increasing our understanding of how these work. It is currently difficult to identify individuals with acoustics as a whole. You really do need like an array setup to be able to take sort of abundance measures or density measures at the moment, which reduces the spatial scale of what you can achieve with your study. And large scale data sets are difficult to analyze. I think we're in no shortage of being able to collect acoustic data sets right now, but the pipelines needed to analyze these large amounts of data are lacking, but are in development at the moment. And there's a lot of work being undertaken at CEH for this right now. And then the final slide. This was a little bit of a wish list that I came up with a while ago of if I could have everything I wanted in terms of acoustics, what would I want? And in terms of the hardware, I want it to be cost-effective hardware and software, reliable and robust technologies across different environments, especially places like the tropics, effective storage, access and transfer of big data, and reliable power sources, which is quite hard to achieve. And in terms of the software, real-time monitoring would be fantastic. Onboard processing, so edge processing, triggered recordings, accessible, accurate species classifiers, and the ability to monitor 24 hours a day. And in general, I just think with acoustics, we do need these multi-dimensional data sets and the ability to monitor long-term temporally. So I think that's it. I hope I didn't go over too much. So I think, as Nikki said, if anyone has any questions, please put them in the chat.
We'll send around the answers by email. We'll also add it to the YouTube video, so they'll be there for reference. So thanks very much. I will move on because we're a little bit behind. Move straight on to Ella Browning from the Bat Conservation Trust, who's going to introduce our workshop session on probabilistic data from AI. So over to you, Ella.
Hi everyone, I'm going to try and keep this as brief as possible just so that we have more time in the breakout sessions. This is just sort of intro to the workshop about the kind of use of probabilistic data in biodiversity monitoring and conservation research, and this relates to the sort of new types of recording and that we've heard a bit more about this morning. Traditional biodiversity monitoring has sort of very much been about people going out in the field and collecting data. And so there's lots of different ways that people do that, whether that's sort of transect surveys, quadrats, sort of just point count surveys, or sort of investigating and counting things in the field. So this is sort of the data from this comes from usually from a human recorder, and then there'll sort of be a binary probability associated with that record based on someone says, yes, I think it was that, or yes, that was there, or no, it wasn't there. But then there are some other sort of biases associated with that in terms of the inter-observer biases. But recently there's been all these sort of new tools for biodiversity sort of monitoring led by sort of rapid development in the technology, and we've just heard quite a lot about that this morning. So things like the acoustic sensors, camera traps, new ways of tracking species, satellite monitoring data, eDNA. I forgot about drones this morning, and sort of also lots of new apps for collecting data. So those are kind of like the new tools in terms of the actual technology and collecting it, but then there's also all the new software and algorithms and AI tools for either collecting the data or sort of extracting the information that we want out of the recorded data, whether that's audio or vision and things like that. So these are things like the BTO acoustic pipeline with bat classifiers, BirdNet, sort of some vision camera trap ID tools like MegaDetect, and an increasing sort of growing number of tools that are really changing the way that we're monitoring biodiversity and sort of collecting data for national recording schemes. So just as a quick example of how at the Bat Conservation Trust we're using some of these tools in our surveys, just to kind of frame what we're trying to ask with the workshop this morning. So we have some new surveys which are based around acoustics for monitoring bats in the UK. Two examples of these are Nightwatch and British Bat Surveys. These are our new citizen science surveys, and we're using acoustic sensors at the moment. These use audio moths, and this is so instead of in the traditional way where an observer might go, a citizen science volunteer would go out and record data in the field, they'd be there and they'd say, yes, I saw this many bats. They just put an acoustic sensor out. It does the recording for however many number of nights, depending on the survey, sort of 1 to 3 or something. That they then sort of send that recorder back to us with the data, and then we use our sound classification system to extract the relevant information from those recordings. So we're extracting the bat species from those recordings, and then we use that we use that in a sort of trend analysis, and the other sort of occupancy and spatial analysis that we're doing, and what that sort of actually looks like in terms of the data that we're now getting out from these surveys is, instead of having a list of this is what bats and this is how many, we have an output of our classifier which generates the data that we're actually using, which tells us what species the classifier thinks it found in that recording, and then we have an actual probability associated with how confident our classifier is that it was that species. So instead of that binary yes and no, we actually have between 0 and 1 a sort of probability associated with that, and that varies. So sort of within a recording and within the sort of number of falls that were detected. And that varies, and we have a classification probability as in how confident it is that it's that species, and a detection probability and how confident the classifier is that it's a bat, whether or not it's a bat. And then also associated with our classifier that we're using, which is bat detect, there's a sort of performance of that classifier as well, which is sort of underlying how well it's performing in general. And so these precision recall graphs here show per species how well overall the classifier is performing, and you can see that between each different coloured line represents a different UK species, and that varies depending on the species. So this, where the classifiers performs best, that's where we have the line that goes sort of across the top and down the right side, and then the lines which sort of are going more across the middle are where the classifier currently isn't performing as well on those species. So these sort of new tools and monitoring methods means that we have a lot, sort of our biodiversity records and monitoring records have a lot of different metadata and associated biases with them, and that's bringing some new challenges and some questions about how do we actually deal with that in our sort of biodiversity monitoring schemes and recording schemes. So just sort of thinking about some challenges and questions that we'd really like you to think about in the workshop and in the breakout groups now. So sort of biodiversity record centres particularly are receiving an increasing number of records, and this is because of all these new technologies and applications and AI tools. And currently, particularly within some of these records centres, there's no facility for recording the sort of how that data was collected and how that species classification was made. So it's not clear whether these are sort of human identified or AI tool identified. So there's no metadata included in that, and the algorithm used is really important because there's the variation in performance between the algorithm, between different algorithms and on different species. And the sensor type used to collect that data, if that data was collected with an acoustic sensor or a camera trap, the performance of those varies incredibly between devices and between microphones used, and the sensitivity associated with that and the sort of detection range of those can vary. So things like that are really important and currently aren't being included in a lot of these records. As I said, the probability associated with those records is no longer binary. So how do we incorporate that? Should we be incorporating that sort of range in probability in our occupancy and trend analysis, and how could we do that? And finally, just thinking about, so instead of just having the sort of a person's gone out and said that they've seen it, there's actually a record of that in terms of there might be a recording or an image, a picture of the species or of the habitat that has been classified there, and should those be included, and how should those things be verified? So that's a sort of quick introduction and what we're hoping to get out of the workshop this morning. So what we'd like to think about and what we'd like you to discuss this morning is we would like to get some background and understanding of how people in different recording schemes are using these monitoring techniques, and whether you are using these new technologies and classification tools, or if you're not, and if you're not, are you investigating the use of these techniques, or why might you not want to use these techniques, and just thinking about what the sort of challenges and issues might be for using this type of data in your field or in your recording scheme, and how might this be sort of incorporated into the sort of current biodiversity recording infrastructure. So if there's any quick questions, or if we want to get straight into the breakout groups.
It's probably best if we can try and get straight into them, and we can deal with questions when we're in the group. But if there are any questions for Ella, then pop them in the main chat as well. So I think Nikki is going to allocate us all to breakout rooms at this point, and there should be a facilitator and a scribe in your breakout groups to help with the discussions, and some Jamboards associated with collecting some information from your thoughts. And we will, we'll come back together just very briefly for a couple of minutes at the end, just before 11:45, to probably not do a huge amount of feedback from these groups, because there's going to be some follow-up afterwards about them, and we will then just wrap up the meeting then. So we'll see you soon. So thanks very much, everybody, for coming back into the main room. I hope that everybody had some interesting conversations there. I think that was very useful from our breakout group. And hopefully there weren't too many technological hitches or anything there. So I just wanted to wrap up the meeting really today by saying thank you very much for everyone for coming. I think there was a lot of different but related content today, which I hope you found interesting and useful. I will just share my screen rather, as a reminder of the events that we've got coming up over the next few weeks, and it would be great to see lots of you at them, where we're going to be having the next two are sort of similar events, but lots of presentations and some discussion sessions as well. So we will be recording all the sessions, so if you can't make any of them, then do catch up on YouTube if you're interested. And it's been really useful to hear so many people expressing interest in being involved in ongoing discussions. And I think BCT and JNCC will probably be involved in touch about this discussion session that we've just been having separately as well, to try and work on capturing and gathering together all the points and recommendations that you've been making today. So I think that's everything for today. So I will close miraculously exactly on time, and we'll hopefully see all of you again soon, and have a good day. Thank you very much. Bye-bye.